Two black holes are about to smash into each other. Matt Eastone. Filed Black Holes. September 16, 2015, 1 p.m. Top image, numerical simulation of two merging black holes performed by the Albert Einstein Institute in Germany via Werner Binger/Wikimedia. 3.5 billion light-years away in the Virgo constellation, two supermassive black holes are on the verge of smacking into one another. In 100,000 years, their cosmic collision will send ripples across the fabric of space-time. Merging black holes wield some of the most powerful forces in the universe, and they may hold the key to observing the gravitational waves predicted by Albert Einstein nearly a century ago. But these formidable collisions have proven extraordinarily difficult to detect. Now, using a simple optical trick, a team of astronomers finds strong evidence to support the existence of a black hole pair, whose members are only a light week apart, nearly 1,000 times closer than any other pair of black holes we know of. Some people think these systems are always going to be hung up at large separations. Columbia astronomer and senior study authors Zoltan and Heyman told Gizmodo. Our study is important because it shows that, yes, black holes can reach very small distances from each other. The method used to detect the cosmic duo, described today in Nature, could help astronomers root out more such black hole pairs and observe an actual collision. Using light to see darkness. Supermassive black holes, bodies so dense that not even light can escape their gravity, are found at the center of nearly every galaxy, including our own. When galaxies collide, their black holes spiral toward one another, forming a binary pair. Over time the pair will continue to creep closer together until eventually, one cannibalizes the other. Observing black hole binaries directly is very challenging, but we might be able to detect them through quasars, beacons of bright light that black holes emit as they burn through cosmic gas and dust. Normally, a quasar will flare up randomly, but when two black holes are on the verge of colliding, theory suggests that their quasar will begin to flicker at regular intervals, like a light bulb on a timer switch. A bright quasar at the heart of a distant galaxy cluster. Image credit, NASA/CXC/SAU/AC Miginauskak, et al. Optical, Gemini Ops. In their new study, Heyman and colleagues focused on an intriguing quasar known as PG 1302-102. Previously, astronomers learned that this quasar brightens by 14% every 5 years, suggesting the presence of a pair less than 1/10 of a light-year apart. Heyman's group wanted another way to validate the binary's presence. Their solution turned out to be shockingly simple: the Doppler effect. Remember that one from high school physics? It's the reason an ambulance siren becomes higher-pitched as it moves toward you. As an observer, the sound waves are reaching your ears at shorter intervals and higher frequencies. Only in this case, we're talking about a black hole moving slightly closer to and further from the Earth as it orbits another one. And instead of sound, we're talking light. It turns out, these objects are moving so fast you get a relativistic Doppler shift, which gives you a change in brightness as they circle one another, Heyman said. Sure enough, when Heyman and his colleagues examined images of PG 1302-102 collected by NASA's Hubble and Galaxy space telescopes, they observed periodic variations in the quasar's UV light spectra that followed a 5-year cycle. Avi Loeb, chair of Harvard's Center for Astrophysics, told Gizmodo that while the new method is interesting and plausible, we need more data points to verify it. Heyman agrees. His team is now in the process of investigating nearly 100 more quasars from a set put together by a team of Caltech astronomers earlier this year. More discoveries like this one mean better chances of witnessing an actual black hole crash and the gravitational waves that could unlock some of the deepest mysteries of the universe. The detection of gravitational waves lets us probe the secrets of gravity and test Einstein's theory in the most extreme environment in our universe, black holes, said the study's lead author, Daniel Orazio, a graduate student at Columbia, in a statement. Getting there is a holy grail of our field,